Hello, today we're going to do some graph transformations. In particular, we're going to look at translations with respect to the y-axis. That means we're going to be moving graphs up or down. We're going to do translations with respect to the x-axis, which means we move a graph to the left or to the right. We're going to be doing reflections in the x-axis along here, so we're flipping a graph over. So we are flipping a graph over the x-axis, and we're going to be doing reflections in the y-axis, which means we're going to be flipping graphs around the y-axis here. Now, before we get started, it's worth being clear what f of x means. This does not mean f multiplied by x, where f and x are numbers. F of x means a function of x, a function of x. So y equals f of x means y equals some really mundane expression in x, so y equals 3x plus 1. So f of x is equal to 3x plus 1, or it could be 2x squared, or half x squared divided by 3. Any of these could be f of x. So let's get started. Okay, let's start with a y-axis translation. Let's imagine we have the x squared function. So y is equal to x squared. Now f of x is x squared, and we're going to add a constant a to it. So if we add, let's say, 2 units, then we would move this graph upwards 2 units, and it would look something like this. In the same way, a can be a negative number, so we could say y is equal to x squared minus 2, in which case we would move this graph down 2 units, minus 2, and it would look something like this. Very good. Now let's consider a straight line graph. Let's say y is equal to 2x plus 1. So f of x is equal to 2x plus 1, and we're going to add a constant to it. But let's first draw this graph. Y is equal to 2x plus 1. We can say it's something like this. And now if we add a constant to it, we can say y is equal to 2x plus, well, if we add a constant, let's say 2, then adding 2 to 1 makes 2x plus 3, so we would have, this is 1, 2, 3, 3. Our graph would now have moved up 2 units. It's about parallel. Now, in the same way, we can take units away from this as well. A can be a positive or negative. So we could say y is equal to 2x. Let's say a is equal to negative 2. So negative 2 plus 1 is minus 1. So let's have a new colour for that. And our new line, y equals 2x minus 1, is about here. The graph crosses the y-axis at minus 1. Lovely. So just to summarise, this is this line, this is this line, And this original equation, where a was 0, is this line here. Now let's look at translations with respect to the x-axis. The form this takes is y equals f of x minus a. And this means anywhere you have an x in your expression, you replace the x with x minus a everywhere. So let's say we have y equals x squared. We have y equals x squared. And let's say we want to slide it along x minus 2. We want to move it 2 units. Now, these are counterintuitive. We would think with the minus, we would be going towards the minus direction. But this is not what happens. They go the wrong way. So the new graph has been moved 2 units to the left. 2 units, we'll say here. And our new graph looks like this. Now, in the same way, let's say we have a new function, y equals x plus 2 squared. Again, this goes the wrong way. Instead of going towards the positive direction, it moves to the negative. So we're moving it to the left. So we have, let's say, minus 2 here. And our x squared function ends up here. Now let's look at reflections in the y-axis. This one can be quite intuitive. If you imagine you have f of x, but all of your x coordinates are flipped. So if you have, let's say, a line, your equation is a line, then your x coordinates, every x coordinate gets flipped to the wrong side. So this piece gets flipped to about here, here. This piece gets flipped to about here. This piece gets flipped to about here. So we're just reflecting along this line here. So this piece gets flipped to here. This piece gets flipped to here, and so on. And you can see that we've now made a line that kind of goes like this. Very good. So let's do another one. Consider we have the function y equals x minus 2 squared. We just looked at something similar. So x minus 2 squared looks a bit like this. That meets the x-axis there, -2. And if we reflect this in the y-axis, it's almost the same as saying we've moved it to the left by 4 units, because we end up with the graph over here, but it's just been flipped along this line. Finally, let's consider reflections in the x-axis. These take the form of y equals negative f of x. Now, let's say our function was x squared. Then, if we take the negative of all of those, then we are just flipping all of the positive y points into negative y points. So this graph just gets flipped with respect to this axis. This is a quite intuitive one and easy for most students to master. But instead of leaving it there, I want to make things a little bit trickier to help you think about what's actually happening with the reflections. So here we have the function y equals tan x. So if we're reflecting in the x-axis, everything on this side of the line, the top side, gets flipped to the bottom side. So let's say our reflection along this piece here from 0 to 90 degrees gets flipped like that, and everything from 0 to negative 90 degrees gets flipped along this line here, so we end up with that. So now, because we have symmetry across this line, across the y-axis and across the x-axis, we can say that the tangent of an angle, say negative 45 degrees, the tangent here, that's got a value of negative 1. This value is equal to the negative, let's say 45 degrees here, 45 degrees, this is equal to 1. So this angle, negative 45, is equal to the negative of the positive angle. That is, the tan of a negative angle is equal to the negative tan of that same angle. Isn't that beautiful? And that is a trigonometric identity. Lovely. If you've enjoyed the video, like, comment, share and subscribe. See you next time.